In this video, we will look at interpreting slope and y-intercept for linear models. And what you will find in this video is in these exercises is you will find your scatter plot based on some sort of situation, some scenario, and generally you'll be asked to give either the y-intercept or the slope of a line of best fit that has been fitted to the data. So we'll take a look at it. We'll take a look at a couple of questions right here. Okay, so the graph below shows the relationship between hours spent on video games and hours spent on homework last week for students in Joyce's class. Joyce created the following scatter plot and regression line to show this relationship. So the fitted line is a y-intercept of 23. So we can see that right there. Here's your y-intercept of 23 on the fitted line. And we're being asked what is the best interpretation of this y-intercept. So what is an interpretation of this y-intercept? Well, let's take a look at the data right here. This data right here shows the hours spent on video games on the x-axis and the hours spent on homework on the y-axis. It's telling us that if somebody in the class spent 0 hours on video games, then there is a high likelihood that they spent around about 23 hours on homework for that week. Okay, so if we take a look through our possible answers, we have the model indicating the student spent 0 hours on video games will average 23 hours spent on homework. That's exactly what we just said. You can see the other options there. Joyce spent approximately 23 hours on video games. Well, Joyce is doing the measurement and not measuring herself, though I'm sure she's part of that data. But it's the group, the class entirely. The model indicates the students who spent 23 hours on video games will average approximately 0 hours spent on homework. Well, if you spent 23 hours on video games, according to this, you're way down here somewhere, and it looks like you'd spend a negative amount of time on homework. It's certainly you probably spend at least 0 time on homework. So that is probably true based on the data, but it's you can't know for certain. Same with Joyce. You can't know for certain. Certainly this dot up here could be Joyce. We're not sure. We don't know for certain. Joyce spent approximately 23 hours on homework. Exactly. We don't know for certain. This could be Joyce up here, but we're not sure. The data isn't sufficient to tell us exactly that. But what the data does tell us is this first one that the model indicates the students spent 0 hours on video games. It's 0 on the x-axis. Spent on average 23 hours on homework, and that is the y-intercept. Let's take a look at another one. So Surya gave each member of his family a different playlist of random songs to listen to and asked them to rank each song from 0 to 10. He compared his family's rankings with the release year of each song and created a following scatter plot and regression line. The fitted slope of the line is the fitted line is a slope of 0.096, and what is the best interpretation of this slope? So we're being asked to interpret the slope in this one. So taking a look at this, here's your release years from around about 1950 all the way through to 2010, and what we see here is that the scores decrease as we go along. That's our slope of 0.096. So the newer the song is, the lower score it gets in its ranking based on this data right here. So let's see what kind of statement corroborates that. So the song released in 1950 would have a rating of about 8.75. Well, 1950 is down here. That is a y-intercept, and it would have a rating of 8.75. That is true, but that's a y-intercept. That's not necessarily talking about the slope. So though this here is true, though option A is true, we can't jump at it right away. Okay, so let's be careful with that. A song released in 1950 would have a rating of 0.096. Well, that's just not true. The rating of negative 0.096 would be right down here, and that doesn't even make any sense. We're talking about as you go down, it goes down 0.096 each time. So that is certainly not true. On average, each 1 year increase in release year is associated with a negative 0.096 point change in score. And this is the one we're looking for. Each 1 year increase in release year, then each 1 year increase in x-axis corresponds to slope change in release year. So whatever the slope is, and we've been given the slope here, negative 0.096. So that's the slope change in release year. So we're going down negative 0.096 for every year that we go along in our timeline. So this one here is the one we're looking for. And when we're analyzing slope, that's what we should see. We should see a comparison of the x-axis range to the slope, or to the change in the y-axis based on it. This one here, each 1 point increase in score is associated with a negative 0.09 year change in release year. This one can't be true because what it's doing is it's comparing the y-axis to the slope, which is not what we're actually looking for. It's the x-axis and the slope is relating together in this one. So I hope that's enough information for you to go by. If you've got any questions, let me know.